doing in the context of exploring the direction we want to go forward at the bank, but also in web development in general, and how we are continuously being asked to make decisions about frameworks. Always, shall we embrace Angular? Let's get the new Angular. Should we go to the old Angular or stay with the old Angular? Should we go to React? Should we write a component library in React, or should it be written in Angular components, or should it be written in plain vanilla components, etc., etc. So this has been an ongoing series of debates at the bank where they just can't make an easy political decision about this stuff. So one of the reasons is because frameworks have become highly politicized within the organization. Basically, you can't mix frameworks. So if you're using Angular, you can't use a little bit of React here because that would cause political rather than technical problems. So what we've been exploring, and what IB's been exploring as well, is the idea of separating the issue of the framework from the component library to essentially try and make, go back to first principles about what frameworks bring to the party, and where we should be proceeding, and what kind of hybrid approach is likely to be the most beneficial, because every approach ends up being sort of a hybrid. So going back, I just want to sort of just reiterate a little bit about the history of how we got to here where we are in front-end development. We started with just JavaScript and HTML, which is really hard to do DOM manipulation using create child and query selector, which is actually a recent addition, but it's still, there's a bit of work that's involved in manipulating the DOM directly. So one of the most popular early developments, hope that comes back, please come back. Oh, yes, okay. Thank you. I don't think don't know what that is. Okay, let me just make sure my phone has got bandwidth, is providing bandwidth. So the main thing is then we moved to jQuery, and then after jQuery we started to move towards declarative styles of programming, and that's where Angular.js first came along, where you could start working in a straight HTML template, use some little curly braces. It looked a lot like JSP and back-end style techniques, ASPs, and all of those sorts of cold fusion and so on. People embraced it for the front-end development. So Angular was the first to bring that. And of course React followed that on with their own approach to the same approach of delivering templates to the user, so users can work in the HTML directly, but they're really working in the JavaScript. They don't have to do direct DOM manipulation. And so that's where we are at the moment. Now we have a situation where React has essentially totally wiped the market clean. Basically, they won. So Angular used to be the dominant framework, Angular.js, and then they said, hold on a sec, we're going to break everything, and then you're going to have to completely upgrade. And while we're doing it, we're going to give you a couple of years to think about it while we eventually deliver something that's worth using. And in that time, the market gradually just said, well, React is pretty good. React is really great. Let's move to React. And suddenly, the vast majority of the market has moved towards React. So what does that leave people who are wanting to work out where to go forward? They can either completely embrace React and work in a React universe, do everything in React, write components in React, do everything the way React is. I'll just point out that React is still produced by a single company. JSX is not a web standard. Most of the basic approaches that are there are still essentially in the same way as we were victims of, in a way, of the foibles of the Angular team, and we never really controlled our destiny. Now we're basically handing our destiny across to the React team. So the question would be, what would a company do? Do we completely go all in with React, or do we look around and see what we should do? So one of the big questions is, how do we write our reusable component library? Do we write that in React, for example? And that would be a pretty viable solution. Another one is to pay attention to what's happening with the web browser ecosystem, which has been evolving evolving in the same time since the React first was launched in 2012, 2013. The browser itself has evolved a lot, and one of those areas that has evolved the fastest with the most potential is custom elements and web components, which are a built-in feature of the new browsers and polyfillable to the old browsers like Internet Explorer. What custom elements is, or are, or web components, is an ability to extend the browser's markup. You can, in the same way as an Angular component or directive can give HTML extra powers, like you can have a component that has, like a reusable widget can be written in Angular and it gets added to the HTML vocabulary. The same thing can happen, but for real with the browser. You can create it, you can declare a custom element. You can say this particular HTML element is going to be associated with this particular type of JavaScript, and you can install it into the browser itself without a framework, and from that moment onwards you can start using that new HTML tag. So you can start defining your own tags and what they mean, and that's something that's got nothing to do with frameworks. It's basically at the level of the browser. And so you could write a custom element that maybe gave superpowers to a button, and you could use that in your React application. You could use it in your Angular application. You can use it anywhere. You can use it in AngularJS or New Angular. So really, the interest that we've been showing is in terms of how we can develop custom elements in a way that doesn't cut off the path towards React if we choose to go towards React, but it doesn't cut off the possibility of staying with Angular or going to another framework, Vue.js or whatever. The main thing is not to have to trash all the work that went into a framework-specific component library. And so the idea is how to keep as close to the metal and as close to the browser's capabilities as possible. So what I want to just show you is that we've been looking at what the Polymer team at Google have been doing, but we've also been looking at other third-party libraries and other libraries to just get a sense of what's available. So let me just get rid of this tab in a second. But anyway, so let's just look at, I've used a really simple example of using what would be really traditional JavaScript. What we have here, you're probably aware of the inner HTML property of the DOM. It means you can provide it with a string and it will just create the DOM elements on the fly. It has to parse all that string and then turn it into DOM elements, but it can do it. It will every time you change it, it will rewrite the entire DOM. It'll create new DOM elements every time you update the inner HTML. It's very, very inefficient, but it exists. It has some advantages though. It's declarative. It means that you can think about the HTML directly as a template in the same way as Angular lets you. So let's just, I'm not advocating this, I'm simply using it as a starting point to explain this particular, you can ignore the first import line, that wasn't necessary actually. What it does is we have a div here called ID root. Let's go and get it from the query selector. And then let's have a render function which takes an animal as its parameter, and then it just says inner HTML is equal to, and I'm using ES6 style template literals here just because they're very, very convenient, and it will take the animal and bind it there. So it'll send to the inner HTML hello, break, span, whatever the animal was, close span, close H1. And that will, and then what we do is we call render in an interval. I've got a little flag that flips the value from true or false, and if it's true or false, it sends dog or cat. And here we go. Now, this would be fine, except that it's very slow and it's very inefficient. And it also has other problems. If you apply things like add event listeners and other things, they're going to keep getting destroyed and remade every time you update the inner HTML.
Do you want to use this?
Oh, no, it's
use
okay.
the laser?
Okay, all right, the laser. How do I make it go?
Just press the button. Yeah. Is that working? Oh, no, what?
Yeah, it's working. Oh, it doesn't work on that screen.
Oh, yeah.
Doesn't matter, I think. Thanks. So it's a very low level and not a very good solution, but you can see it, if only we could make it work, is kind of the point. So there are a couple of libraries that exist that One of them is called hyperHtml, which is the first library to have used this approach. It's very easy to get going. If you want to use it with Internet Explorer 11, you do have to do polyfills, which means add a few extra supporting imports. But essentially, we grab the root, and the render function in this case is the same, except that we've imported this little thing here, and we attach that and the DOM directly to this string literal. And this is a very special kind of syntax. The string literal you might have seen before. It's basically a multi-line string. So normal strings can only fit on one line, but a string literal can be spread across multiple lines. I could put carriage returns in there and there'd be no problem. In fact, I probably should, just to make it a bit clearer. If we can basically, it still works, right? And this little thing here is basically a lot like the double curly braces in Angular or whatever in two-way binding or one-way binding. But the main part is that this string, when it's passed to the hyper function with the DOM element, will actually parse that stuff, produce actual DOM, and then only update the parts that have actually changed. So this is not like inner HTML. Even though it looks like inner HTML, what it's really doing is it's building real DOM, and it's actually only modifying the parts that change. In the same way as React works, which is a virtual DOM, where you basically, virtual DOMs are a layer between your application and the real DOM, which you can change, but only when you actually made a real change will the DOM be updated. That's how React works. That's how most frameworks work. But this is using stock standard JavaScript. It's a technique's only been discovered or used widely for the last 18 months. But amazingly, it can be polyfill all the way back to early Internet Explorer 9, I believe. It still works. Obviously, it doesn't have such nice syntax in old JavaScript, but it works quite well in new JavaScript. There's another library which is more famous, or will be more famous, because it's called libHtml, and it's from the Google Polymer team. And they saw hyperHtml and copied it. So essentially it is Google, being a big corporation, going, we just had a great idea. After looking at some GitHub repos, the original author of hyperHtml was sort of calling out Google, how about a little bit of credit over here, because we beat you by at least 6 months. But this one will become significant because the Polymer team, if you've been aware of Polymer has been Google's long-running research and development project but to produce custom elements, web components for everybody to use. And now Polymer is being used, these components that they've been producing are being found on the YouTube site. You can see them in the Netflix site. You can see them being picked up across multiple big name sites because people are embracing custom elements. Even React sites are embracing custom elements. It means you write it in one thing and you can use it in another framework. You're not locked to the framework, you're not locked to the virtual DOM. You just essentially have a lot of freedom if you work in that level. So I just thought, and I thought I'd give you an example in React, doing the same thing again. Again, this is having to use JSX in line here, but basically, so it has an extra Babel step. But basically, the code is the same. We've got a render function. It's a functional component, if you understand React, and it's just basically doing exactly the same thing. Oh, well, there's a little bit of time. I put a little bit of performance stuff on here. Now look at that number. I won't, because I couldn't work out a very good way of how to profile the performance of React. These figures are ridiculously slow, so just bear with me for a bit. Don't treat that as a fair comparison, but I did produce performance metrics for all of the other examples. So here's inner HTML. This is a more realistic example of what's wrong with inner HTML. What I'm doing is I'm just simply, inside that interval, I'm doing the render, but I'm doing it 100 times. And you can't see it change anymore, but I'm rendering it 100 times and then I'm timing the length of time it took. So it's taking, you know, between 1 and 2 milliseconds, you know, something like that. As a typical render. The equivalent in hyperHtml is a tenth of that. In other words, inner HTML is 10 times slower than both this hyperHtml and lit HTML.
So what native JavaScript method it's using to get that performance?
It's under the hood. It's doing the DOM manipulation that we really don't like doing. So the library parses this template into a tree or into a bunch of DOM elements, and it notes the points where the actual changes have taken place.
Just the duration.
In other words, these things. It's chopped it up into a bunch of DOM things and then noticed the points at which it needs to update. So if you need to update the animal, it will change the animal. If it updates the delta, which I've added here, which is the time, then it'll update that. But essentially, it's just making a declarative thing very quickly render to the actual DOM. It's not doing any parsing beyond what you've apart from the initial render. Like I said, I haven't got a fair comparison against React, but I have read articles which have done comparisons against the virtual DOM method of rendering, which is clearly also a massively efficient way of working, which ultimately at the end of the day still has to do DOM manipulation. At the end of the day, they all ultimately have to get down and use DOM manipulation. It's comparable. I won't say one or the other is terribly much faster. So under different conditions, one comes out ahead versus the other. But generally, lit and hyperHtml have both come in at more or less the same and are pretty snappy. So Polymer and Google have embraced this model, and now they're going to do all of their components using this style. So you'll find there's a whole bunch of libraries have already come out. So how much time we got? Oh, well, we're sort of running towards the end, so I'll probably wind it up there and just simply say that the virtual DOM isn't necessary. You can actually, it's not the DOM that's slow, as Andre Giamacci, who invented this hyperHtml, said, it's not the DOM that's slow, it's your abstraction that's slow. So inner HTML is a very bad abstraction, but also if you think about what virtual DOM does, it makes a heavy use of memory in order to do the diffs. It's essentially like Git for DOM manipulation. It's looking for diffs. It's actually got a lot of overheads that this model it doesn't have. These libraries, both lit HTML and hyperHtml, are 2K. And if you think about what a web application is, what does a web application framework actually offer you? What do you actually get from a framework? You get routing, and you get components and data binding. That's it, right? So routing is a solved problem. You just need something to watch the URL bar, and that's actually, you can get third-party libraries to easily do routing. Most of your web application is the view, and the view is made up of components. Now you don't actually need the framework to make those, to control the view. So in theory, while React, you can definitely use components that are written using this in a React application. And there's nothing stopping you, because you might like it for the business logic. You might like it because it does other nice things like uses Redux or whatever. At the end of the day, there's a strong argument that can be made that you could actually swap the whole framework out and write a real application in plain vanilla JavaScript, which is what I just did. I'll just bring up a quick example of a library, of a application that I wrote that uses, when I say wrote, this is your classic thing, you've probably seen it before. It's a classic demo, the to-do list, and this was written using components, and I should put some, this framework has been written completely using hyperHtml. It doesn't have any framework in the conventional sense of the word, and somehow it manages to work just like an SPA, a normal SPA. The only thing it doesn't do is routing. I haven't put the routing in yet. And to give you an example of what it does is, I've got a series of elements. So the simplest element would be, say, the container element, which I'll just bump up the size, and I won't take too much more of your time because I know we're running out of time. Basically, an element, this is a specific class that has been as part of the hyperHtml library, but custom elements all look kind of like this. You have a base class. You make your component as a descendant of that base class. It could be the HTML element class, which is built into the browser. It could be the lit element class, which is built into the lit HTML library. But all this is doing is just giving you some lifecycle hooks, a bit like a React component. We have a created callback, we have a render callback, and there are other callbacks you can have too, like my property changed type callbacks. And this will, and here we go, this is the render function. The render function does exactly what you expect it to do. It spits out 3 smaller elements. In that case, a header. If you remember, it has a top bar where you type into. It has a to-do list, which is the list of to-do items, and it has a footer. And the only data, and what we have, if you take a look at, say, the header, is more of the same. Okay, so basically, it just produces some HTML text. The header doesn't do very much. The one that does the most is probably the to-do list, which has a little bit more logic in it. Again, the to-do list is an HTML element. It has some business logic being injected into it, which is just a bunch of it's like a service. It handles the to-do logic, so it's stuff to do with managing the list and adding and removing from the list and all that sort of stuff. So I call that the controller, and we're subscribing to changes, which basically causes this component to render. That could be done by Redux very easily. And this is the render function. It does nothing much except render the to-do items. And it uses a similar approach to what React and many other things do, which is you've got a list of to-do items, to-dos, you just map over them. So bang, 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 bang. And then I could go into the to-do item, which is the thing that displays the little checkbox on one end and the text. And it has all the functionality of the to-do list, the to-do MVC example, which is kind of it's the benchmark by which frameworks are compared against each other. Is everybody's got one of these to-do lists, and so that's where we're at the moment. There are interesting libraries there are whole projects that are currently shipping using custom elements based either on Polymer, lit HTML, or just generally using hyperHtml and so on. And that's my presentation.
Have you counted the whole size of this how much JavaScript?
Yeah, it's